So far we've looked at a variety of different ways to factorize expressions, whether that was common factors, grouping in pairs, our special types, cross method, product, sum and factor method, and our cubics. So what we're looking at today is what to do if you get an expression that is a combination of all of these. The one piece of advice I would give you is to take it one step at a time. So if there's a common factor, do that. And continue on one step at a time, because if you try and do too many steps at once, it's very easy to make a mistake. So students often get stuck on, well, where do I start when I get a complicated expression? And the first thing I would tell you is to look for the common factor, because that just is going to make life much easier if you take any common factors out first. Then you want to have a look at what's left and say, well, is this one of my special types? Is it a perfect square? Is it a difference of two squares? Is it a difference of two cubes? That's the reason it was so important that you did so many of them. You need to get really, really familiar with what they look like when they've been expanded so that you can easily factorize them. Then if it's not got any common factors, or you've already taken them out and it's not one of our special types, then we need to look at it and say, first, is it 3 factors or is it 4 factors? So if it's 3 factors, then you've got your choice of using the cross method or your product, sum and factor method, whichever one you prefer. If it has 4 factors, we're going to group in pairs. Now be careful, we're used to looking at perfect squares as things like x squared or 9, but perfect squares, difference of two squares, difference of two cubes also work for higher powers, like x to the power of 4, because x to the power of 4 is x squared all squared. Also works for fractions. That seems to be tripping some people up in class. So something like 4 over 9 is 2/3 squared. So you've got to be able to recognize things like that as well. So a couple of examples. Our first one, 16x squared plus 80x plus 100. So first thing you're always going to do is look and say, is there a common factor here? And hopefully you could recognize that there is, and that the common factor for this is 4. Once you've taken out your common factor, then again, hopefully we can recognize that what we have here is a perfect square, because 4x squared plus 20x plus 25 has a term of 4x squared, which is 2x all squared, 25, which is 5 squared, and 2x times 5 is 10x, and our middle term is twice the product. So this will factorize to 4 outside of 2x plus 5 all squared. If you can recognize that that is a perfect square, you are going to make things much simpler and much quicker. If you were trying to go back to your cross method or your product, sum and factor methods, they will work. They will always work, but this is much faster. Our next example is much more complicated. 6x cubed plus 3x squared minus 54x minus 27. So again, first step, is there a common factor? In this case there is. Common factor is 3. So once we've taken our common factor out, we've got 3 outside of 2x cubed plus x squared minus 18x minus 9. And this doesn't fit into our perfect square, difference of two square, difference of two cubes. It's none of those. We don't have 3 factors, so we're not looking at a cross or a product, sum and factor method. But we have 4 factors, so we can group in pairs. So our first pair, 2x cubed plus x squared, has a common factor of x squared, leaving me with 2x plus 1. And then my second pair of negative 18x minus 9, well, we want 2x plus 1 inside those brackets, and we can get that from that if we take out a negative factor of 9. So looking at that expression, we've got a common factor of 2x plus 1, leaving me with x squared minus 9. Now, a lot of students are tempted to stop there and they go, oh look, I factorized it. But what you need to consider is the fact that that x squared minus 9 is the difference of two squares. So looking at that, you can see this is a very complicated expression that we started with, and our end product, 3 outside of 2x plus 1, x plus 3, x minus 3, isn't simple either. But there isn't a single step in there that you're not capable of doing. You can take out a common factor, you can group in pairs, you can then take out another common factor, you can recognize the difference of two squares. Okay, so my advice, no matter how complicated it is, take it back to basics. Do I have a common factor? Do I have a special type? Perfect square, difference of two squares, difference of two cubes. If not, and I have three factors, well, let's go with our cross or product sum and factor method, whichever you prefer. If I've got four factors, let's group in pairs and just take it one step at a time. You can get through it.